All right, so continuing with the second page of our note here, we've got another tough factoring one. So you'll notice that the exponents are all fractions. And so what to do when we have a situation like this? So I'll just make a little note here. So what we're going to do is actually factor out the lowest power of x. That's kind of a good strategy to start these. Okay, so the lowest power of x is going to be our negative half. And so we're going to factor that out. So we're going to factor out an x to the negative half. And then also looking at our coefficients there, we see that we can factor out a 2 as well. So we're going to factor that out. Okay, and so when we do that, so think back to our exponent rules. So when we're dividing exponents that, or like when we have the same base and we're dividing, we just subtract the exponents. So because x, is the same base in both, that's what we're dividing out. All we have to do is subtract the exponents to see what we're left with. So if we factor out this, so first of all, we factor out the 2, we're left with just a 1, or we don't need to write that. And then we're going to have our x. And then I'll just kind of show my work here. So really what we're doing is we're minusing the exponent of what we've divided it by, so which is that negative half. And now for our next term, 6 divided by 2 leaves us with a 3. And then as for our x to the half, we're just minusing out that negative half. And then our last one here, 4 divided by 2 leaves us with a 2. And then we've got our x, and then our original exponent was 3 over 2, and we're subtracting negative half. Okay, so that's kind of what's going on when we go to factor that out. And so let's see what we're left with when we actually go ahead and do that. So we've got 5 over 2 minus negative half, right? So we're adding half. So 5 over 2 really plus 1 over 2 is just 6 over 2, which simplifies then to 3. So we've got an exponent of 3 there. Beside that, we've got our 3 as our coefficient, and then negative half, take away negative half, is just 0. So x to the power of 0 is just 1, right? Just the whole number 1, so we don't need to actually write any x's there. And now we've got our next one, so 2. And now we've got 3 over 2 minus negative half. So that would actually end up being 4 over 2, which would simplify to just 2. So now we've got all whole numbers as our exponents. So it's a little bit easier to deal with. And then we can just use one of the above factoring rules to then kind of factor this expression that we're left with even further, right? By doing, factor theorem and then synthetic division or long division, and then kind of go from there. So the last part of today's kind of review lesson is rationalizing. And so rationalizing is the kind of act of shifting around a square root sign in an expression so that it's easier to work with. So usually that means we want it out of the denominator, and then it might end up in the numerator. But it won't always be like that. So you'll kind of see different examples where we might actually need to get it out of the numerator instead of the denominator, but maybe out of both. And so for today's example, though, it is in the denominator and we want to get it out of the denominator. And so how we do that is we multiply by the conjugate radical. And so that means you've got the same term. So if we're looking at our denominator in this example, we've got square root of x plus 4, and then we've got a minus 2. So we're still going to have that square root of x plus 4, and we're still going to have that 2, but now it's going to be the opposite sign between them. So instead of having a minus between them, we're going to have a plus. And so we're going to want to, here I'll make a little note, multiply it. So you want to move the root sign to the top. So you multiply by the conjugate radical. And because we can't just multiply something and just completely change our expression, we actually have to oh man, sorry about that, multiply it by the conjugate radical over top of itself, right? Because we know that any number or expression over top of itself is just equal to 1, and we can definitely multiply anything by 1 because that doesn't change it. So let's take a look at this example by doing that now. So we start with x over top of x root x plus 4, and then we've got that minus 2. So we're going to now multiply by our conjugate. So that's going to have the same term at the front and the same term at the back, but now we've got a plus in between them. And then we need to make it into a fraction with that same thing as our denominator, so that really this whole thing that we've been multiplying by just simplifies down to 1. So we're not actually changing our original expression. And so going forward, a lot of stuff cancels out here, but maybe it's been a while since you've done this. So I'm going to kind of show all my steps for today. But going forward, don't feel like you need to show all of this work. So in the top, we've got our x being multiplied by everything over here, which is x root x plus 4, and then plus 2. So I'll just kind of keep it like that. And now we've got our first term. So right under our first kind of original expression here, the denominator is a binomial, right? We've got 2 terms. And then in our next one, the conjugate radical also is a binomial, it has 2 terms. So we think back to kind of when you did FOIL, right? You're doing your first times your first, and then, the first times that last one, and then the inner times the inner, and inner times the last. So that's kind of what we're doing here. So we're going to have our first terms, so that root x plus 4 times root x plus 4. So that's just root x plus 4 squared. Now we're going to have that root x plus 4 multiplied to our positive 2, to our plus 2. So that's just 2 root x plus 4. And then we've got now our second term in that first expression there, so negative 2. So we're going to have now minus 2 times that root x plus 4. And then our minus 2 times our positive 2 is just a minus 4. And so now at this step, a lot of stuff starts to cancel out, which is nice. So our positive 2 root x plus 4 and our minus 2 root x plus 4, those will cancel each other out. And then also we've got, our square root symbol cancels out with our square symbol, right? So in the end, we are just left with, let me write the top here, the numerator, x plus 4, and then we've got our minus 4. Now I'll write the rest kind of up here. So keep the top the same for now with that x out at the front. And now x plus 4 minus 4 just leaves us with an x. So you'll see again that these x's cancel out, which will be very important in the next couple lessons that we do. And now we are just left with a nicer expression that's not a fraction. They won't always not be a fraction, but at least even if it is a fraction, it won't have a root on the bottom anymore. So a little bit nicer to deal with. Okay, so that wraps up our kind of prerequisite skills, our review lesson for today. And then we'll be doing some textbook practice on these things, on factoring and on rationalizing tomorrow.